Hello, everyone. I'm Changyi Li from Fudan University. Today, I'm very excited to share our work, AutoControl Arena. I will talk about how we automate frontier AI risk discovery for increasingly capable AI agents. Okay, let me start with a high-level overview. Okay, at a high level, AutoControl Arena turns risk hypotheses into executable experiments. First, given an open-ended risk intent, it builds executable environments and runs agent inside it, and finally generates an evidence-based risk report. So instead of only asking what an agent might do, we can observe that what it actually does. But why do we need this kind of evaluation? Our motivation is that frontier AI agent risks often emerge from specific environmental combinations, including tools, incentives, constraints, and hidden states. And these risks often appear in agent-environment interactions, not just static dialogues. That's why we need this instance-level evaluation. However, building these environments creates a fidelity and scalability trade-off. On the one hand, manual benchmarks are realistic, but often expensive and hard to scale. On the other hand, pure LM simulators are scalable, but often suffer from logic hallucinations. So our goal is to achieve scalable generation with fidelity, pushing towards the Pareto boundary. Okay, to achieve this, AutoControl Arena has three main components. First, the architect turns natural language intent into design proposal. Next, the coder builds an executable sandbox with grounded state. Finally, the monitor audits the trajectory with evidence and generates a risk report. But the key question is, how do we keep these generated environments both flexible and reliable? Our answer is logic-narrative decoupling. In short, the logic layer, or code, grounds deterministic logic, such as files, database, and tools. The narrative layer, or LMs, provides scalable generation and dynamic interaction, such as scenario design or NPC responses. Using this framework, we construct Xbench, which covers 70 risk scenarios. More importantly, we use stress and temptation as elicitation knobs to surface latent risks. But generating environment is not enough. The next question is whether they are meaningful. So next, we perform real-to-sim validation. We successfully reproduce well-known failure cases reported by frontier AI labs such as Anthropic System Card, OpenAI's COT monitoring, reverse hacking, and Apollo researchers in context gaming. After reproducing, we also want to know whether our simulation can predict real-world risk trends. So next, we perform sim-to-real validation. We compare simulation with manually implemented environments across different domains. On the left, the strong correlation suggests that our simulation can serve as a useful proxy signal for real-world risk evaluation. Based on this, let's move to our main findings. Our first finding is the alignment illusion. That says models often show superficial safety as baseline, but catastrophic specs under pressure. What's more, stronger models even show greater safety degradation. Okay, our second finding is that capability scaling is a double-edged sword. For positive scaling, in direct harms, stronger models can be safer. However, for inverse scaling, in complex tasks such as scheming or reverse hacking, stronger models can become riskier. That may be because enhanced reasoning may facilitate more effective loophole explanation. The most important takeaway is that capability scaling does not imply uniform safety scaling. Okay, at last, I will end with three open problems. First, auto-defense from discovered failures. We ask, can failure trajectories be converted into better prompts, policies, or control protocols? Second, co-evolving monitors for strategic agents. Can monitor adapt as agent become better at hidden intent and evading oversight? Third, harness sensitive risk discovery. How do agent architects such as memory, planning, and tool use can change an agent behavior? Okay, to close, AutoControl Arena is our first attempt to make frontier AI risk evaluation more automated and realistic. If you have any questions or if you are also interested in these directions, I'd be very happy to discuss further. Okay, that's all. Thank you.